Okay. Hi, I'm Guillaume Tardif. I'm a freelance developer, and I've been working with Java since 1998. Today I've got half an hour to present you a new feature of Java 8, Lambda Expressions. So we'll quickly see what are Lambda Expressions, what syntax you can use to express them. We'll see some samples of the new JDK8 API, especially in the collections that are using Lambda Expressions. And we'll also go through a few concepts and design choices that have been made in the implementation of Lambdas in Java. So I will use JDK8 Preview to do a coding demo to present all of this. So this is my only slide, and the rest will be coding. And just before we start writing some code, I will just quickly present the tool. So you can actually go on the web and search for JDK8 Lambda, and you'll probably land on this page, which has documentation about the project Lambda, and various links, including a link to the binary snapshots that are available. And then you can download the JDK for your platform. So once you've downloaded this, you end up with a JDK with a completely standard structure, so you can directly include this in your IDE. And you can check as well that you're running with the correct version. So you need to set your path and then check that you're running with version 1.8. So here we're using OpenJDK 1.8 build 63. So I believe I'm actually one version behind the currently available version. So that's for JDK, and I'm going to use IntelliJ for the demonstration. Sorry. Actually, when I first did this presentation last April in Paris for Devoxx France, there was no support for Lambda Expressions in any of the IDEs, so I used Eclipse, which is my favorite. And quite recently, I saw that IntelliJ has some support for Lambdas. And I believe NetBeans also has some support in the latest versions. So I will be using IntelliJ for this demonstration. And we are going to start right now doing a Hello World sample using Lambdas. So I'll write a sample Java class with a main method. Sorry. This is just basic stuff. And the first thing people usually want to try with Lambda expression is create a list of elements and then use a for each method to execute some block of code for each element. So let's try this. We're going to create a list of strings. And I will call this sorry. I will call this names. So we've got our list of names, and on this list of names, we can call a for each method, which takes a block as a parameter. So that's a new method that you can call on the JDK8 collections. And this is where we can use Lambda. So we can, instead of creating inner classes and stuff like that, you can directly specify your block of code using a Lambda expression. So for each element of the list, I'm going to do just a println. Println x. And I can execute this, and it should print out the different names in my collection. Great. So here we've got our first Lambda expression, which takes X a string as a parameter, and then execute system out println. So we can notice that we don't have to specify the type here. It's inferred by the compiler, because the compiler knows that we have a list of string on which we apply the for each method. In some cases, we also might have Lambda expression with several parameters, in which case we'll have to specify braces to specify the list of parameters, and then we can use a comma-separated list for the parameters. And if we want to specify the types, we'll do something like this, string x and y, and this would be a Lambda expression with two parameters of type string and int. So here the for each method requires to have a Lambda expression with only one parameter, since it's applying this Lambda expression for each element of the list. And the compiler does type inference, so we can remove the string, and since we have only one element in our Lambda expression, only one parameter, sorry, in our Lambda expression, we can remove the braces here. And on the other side of the arrow, we've got just one simple expression with only one line, but we could have several lines of code here. And if we want to do this, we have to specify curly braces to delimit our block of code. So this will be working as well. And if we come back to our basic Lambda expression. So you can see that you've got several levels of syntax corresponding to the complexity of what you want to express in your Lambda expression. And there is one last syntax that I've not gone through yet. You can actually, instead of writing a complete block of code, you can create a reference to an existing method that has the required signature. So in our case, we could do a reference to the println method directly. And you do this by calling system.out and then double column println. So this would be a reference to the println method, and you can use this syntax to make references to static methods, to instance methods, and to constructors as well, depending on the required signature, of course. So these are the different syntaxes that you can use for Lambda expressions. And let's come back to the first one that we had. So in this case, we only have a basic Lambda expression that has just one parameter, a string, and it returns void. And in some other cases, we're going to have a Lambda expression that will return actual values. So one example would be if I want to filter my list before printing out the elements, I could call a filter method, and this would have to, I would need a Lambda expression that returns a Boolean to specify for each element if I need to keep the element or extract it from the list. So if we look at the names collection again, let's see what do we have in store. There is no filter method directly on the names collection, but we have a stream method that gives you access to the filter method. And here, filter will take a predicate as a parameter. So actually, just before I continue writing this code, quite big warning on what I'm showing right now. All these API for each filter and stream are still quite unstable, and if you go from one build to another of the JDK, you might have some important changes. Actually, the stream method was introduced like 2 months ago. So just be aware that these are only examples of the current state of the JDK preview, and it might still change until the JDK is finally released. So anyway, let's continue with this example. We want to have a Lambda expression here, which is a predicate, and that will express which element I want to keep in my list. So I might want to keep only the short elements. So let's say here I'm going to keep the elements that have less than 5 characters. And here it's giving me only the shortest one, so that's nice. But my line of code is becoming a bit complex, so I would like to extract these Lambda expressions into variables. So I will extract this in something called short names. Short expressions. Here we go. And the second one, I can also extract something called display, for example. So I've got my two lambda expressions here. I can simplify this a bit more, actually, and just have a predicate of string and a block of string. And now we can have a look at what exactly is this predicate and this block. Actually, these are two new interfaces that you will find in the java.util.functions package. So that's a new package in JDK8. And if we look at predicate, so it's an interface, and it's an interface with one abstract method that takes t, so in our case it's a string as a parameter, and it returns a boolean. And there is some stuff below, but for the moment, just keep in mind that we have an interface with one abstract method. We're going to look at what's below later on. And if we look at block, it's also an interface, and it also has one abstract method that takes a string as a parameter and returns void. And again, just keep in mind for the moment that we have one abstract method. We'll look at the bottom part later on. So the basic rule is that you can use Lambda expression whenever you have an interface which has only one abstract method. And such interfaces are called functional interface. And what is quite nice is that you can use Lambda expression as well for existing interfaces with only one method, such as runnable or callable, for example, from the Java threading APIs. So without having done any change on the existing runnable interface, you can straight away use Lambda expression whenever a runnable or a callable is required in the Java threading APIs. Same thing for the action listener interface, for example, in the AWT API. So even for APIs that date back from last century, like AWT, you can straight away use Lambda expression in the add action listener method to specify the content of your action associated to an AWT button. So that's quite good for the adoption of lambdas in existing code, and you don't need to to upgrade or to recompile your existing libraries to make them Lambda enabled. So this would work as well, of course, with external libraries from Guava or from Hibernate. As soon as you've got an interface with only one abstract method, you can use Lambda expressions. And you can actually create your own functional interface. So I could create an interface action here with only one method, and I will be able to use a Lambda to instantiate this interface. So I've got my functional interface action, and I can create a variable. Let's call it display2. And here I'm going to do pretty much the same thing. Println x and display2 execute. And here we can actually display hello world that we still haven't seen on the screen yet. Great. So actually you can notice that on purpose I've used exactly the same Lambda expression here that I was using before with the block interface. So the block interface and the action interface have nothing in common. They don't inherit from one another or anything like that. And I'm passing the same value to a block variable and to a display variable. And if I try to use the display variable here to affect it to the action interface, of course it's not going to work. So if I try to do this, IntAJ is telling me that the two different types are not compatible. And actually, it's possible to do this. This is a bit of a trick, but you could do a method reference to the apply method on the display variable. Since it has already a method that has the correct signature, you can use this method reference. But just going back to this code sample here, the same Lambda expression can be affected to a block interface or to an action interface. And this leads us to what is called target typing in the documentation about Lambdas. The Lambda expression itself actually does not have a type. It's only when you affect it to a functional interface that the Lambda expression gets a real type. And so this is called target typing. And this is quite different from the Lambda implementation, for example, in Scala, where when you create a Lambda in Scala, it is of type function, which is a parameterized type with a return type and specific parameters. So as soon as you write a Lambda expression in Scala, it has its own type. And this is not true in Java. In Java, the type of the Lambda expression is determined when you associate it with a functional interface. And the advantage of this design solution, or this design choice, is that Lambda expression can be used straight away with any functional interface, including the existing ones like callable or runnable or action listener, or the Guava functions, for example. So we've seen the notion of functional interface, we've seen the concept of target typing. And now if we go back to our predicate interface, let's have a look again here. So I told you that there was some stuff below that at the beginning we were just ignoring. And if we look at what we have in predicate, we have an AND method, we have negate method, OR, and XOR. So basically this method allows you to do some training on predicates, and you can write things like predicate1.end, predicate2.or, etc., etc. And what's completely new here is that these methods have a default implementation. So we're still in an interface. This is interface predicate. And this interface has one abstract method test, and it has additional methods that have an implementation. So this is a completely new construct in Java 8 that's been added to the Java language. And it's called virtual extension method. And basically it means that when you implement your predicate interface, you have to provide the implementation for test, but since the other methods have already an implementation, a default implementation, you can, but you don't have to. You can override this default implementation, but you don't have to. So that's a huge change in the Java language, virtual extension method. Of course, when you think a bit about it, it brings pretty much, well, it brings lots of things in the Java language. Especially it brings multiple inheritance, since our Java interfaces now look exactly the same as traits in Scala, for example. You can have abstract method, and you can have method with implementation in the Java interfaces. So this brings multiple inheritance and questions like the what's happening when you've got diamond inheritance and things like that. So it opens lots of doors, and some of them can be good, and of course people will have to be careful with when using this this feature. But coming back to our example, why exactly am I talking about this in this talk related to Lambdas? Well, it turns out that the reason for introducing these virtual extension methods is quite related to the introduction of Lambda in the Java language. When you introduce a feature such as Lambda in an existing language with existing libraries, sorry. You have to, well, one of the first things that people want to try is to use Lambdas on your on collection interfaces and collection classes. So somehow you have to provide the Lambda feature and features such as filter, map, and reduce on the collection libraries. And basically there are three solutions for doing this. The first solution is, well, just add this for each method or filter method on the existing collection interfaces, so that anyone using list can do a list.filter. And well, the bad thing about this solution is that you're adding new methods to existing interfaces, and you've got lots of Java projects that have their own implementation of list or set or iterable. So if you add new method, then you're breaking the code for lots of projects, and you're also breaking the code for lots of existing libraries. So you would have to rewrite some Guava classes, some Hibernate classes, etc. So that's not really good for the adoption of Java 8. The other solution is, well, we can't really add methods on those collection interfaces, so let's create a brand new Java package called java.collections2, and we can create a new list interface, a new iterable, etc. And obviously it's also a crappy solution, because then when you're using Hibernate, you get an old list and you want to be able to use your filter method that's on the new list interface. So it doesn't work at all. And the third solution is, well, we'll try to add some new concept in the Java language that makes us enables us to make evolutions on the existing interfaces without breaking the implementation that already exists for those interfaces. So basically, that's the solution that's been chosen. And virtual extension methods are really a way to make evolutions on existing interfaces without breaking the code that is already using these interfaces. So these virtual extension methods are used to implement the for each method and the stream methods on the, in this case, on the list interface. We can use the stream method, and if you already have a class that implements list in your project, you don't have to implement this stream method because it has a default implementation in the JDK. So that's also a choice that has been done with the concern about JDK8 adoption and how we can make this compatible with existing code and existing project as much as possible. And here again, we can, of course, try to create our own virtual extension method. So if I go back to my action interface, I can write a new method, let's call it execute uppercase. And I will provide a default implementation for this, which is, well, just a shortcut to the execute method, but first I will turn my text to uppercase. Execute. And once I've done that, I now have a choice of two methods on my display2 variable. And I can run this sample to have hello world displayed in capital case. So just to wrap up on this sample, we've seen the various syntaxes that you can use with different level of syntax depending on the complexity of the Lambda expression you want to write. We've seen the concept of functional interface that have only one method, one abstract method. So in this case, you can see that the method with a default implementation does not count as an abstract method for the functional interface, of course. So functional interface must have only one abstract method. We've seen the concept of target typing and the fact that Lambda expression does not have a type until you actually associate it with a functional interface. And then we've seen the virtual extension method, which brings a lot of new functionalities and a lot of new things in the Java language, including things like multiple inheritance. But basically, this virtual extension method are really a good way to make evolution on existing libraries and existing interfaces. And in our case here, you can see that they allow us to have quite nice shortcuts to functionality without making without making things too complex for the people to implement our interface. In the case of predicate or block, they allow us to have quite fluent APIs where you can train your calls and do things like predicate1.end, predicate2, etc. And since we've got still a couple more minutes for this demonstration, I will finish with, well, outside of the of IntelliJ. Actually, I wanted to test Lambda with a bit more complex example, actually more than just one class completely alone. So I've created well, I took one of my existing project, foo_barkix implementation that I had been done previously. I put some Lambda expressions in there, and so basically it's a Maven project with a couple of dependencies and some libraries for unit test as well. And I just wanted to check that things were running smoothly with Lambda expression, and it's actually it actually is. So you just have to, well, you just have to specify in your poem that you're using source level 1.8, and then Maven will just actually delegate all the calls to the JavaC compiler. So this would work quite nicely. So from here, if I just run Maven clean verify, this will run all my unit tests and execute the code that contains Lambda expression on this project. So this worked really without doing any weird stuff with Maven. You just have to specify the source level and change your code using Lambda expressions. And if I switch this to source level 1.7, I've got quite explicit message saying that here Lambda expressions are not supported in source 1.7. So that's quite nice as well, and it's just because Maven is simply redirecting everything to the JDK tools, the JavaC. And this is it pretty much. I actually have just one more slide. Do you have any questions? Yes?
Does it have to be an interface with one abstract method, or can it be an abstract class?
I believe it has to be an interface with one abstract method. And there are also specific cases, like if you create an interface with a method that already exists on the object class, I think it does not count as an abstract method in this case. Yeah.
Double inheritance, and there is both the same method in both interfaces, which method is it going to use?
So your question is about diamond inheritance. So if you have double inheritance and the same method is implemented in these two interfaces with two default implementations, the compiler, well, if there is any ambiguity about the method the method implementation to be chosen, the compiler will force the developer to be specific and to make actually a new default implementation that will, or a new implementation that will point to the one that has to be chosen. And if you've got several levels of inheritance, the compiler will choose the most specific implementation that is available. Yes.
Is a lambda converted to an anonymous class?
Sorry, say that again.
Is a lambda converted to an anonymous class?
So the question is a lambda compiled to an anonymous class? I don't know the exact detail, but no, it's a bit more complex than that. And there are there are quite huge optimization done on Lambda expression. So it's more efficient than compiling it basically to an anonymous class. I haven't checked the exact details about this, but there is quite a bit of work that has been done to optimize Lambda expressions, and it's quite more complex than just compiling it to an anonymous class. Any more questions? Okay, thank you very much.